to like go to Brianna. So, honey, there's an electric one. There's an electric one. Okay. So let me ask you this. What operation is happening in this problem number 13? What operation? There's a little dot here. What does that mean? Multiplication. Okay. So when you multiply the numbers. So I get 3 times 4 is 12. And what do we do with the exponents? Add them. Okay. So really good question here. How many A's are in this problem? Total A's. Perfect. How many total B's are in this problem? And how many total C's? Done. I think maybe we've started overthinking those. Okay, now let's go to number 15. This one's spicier for sure because it's got the negatives. So the first thing we notice is that it's division, but I am going to circle this one and this one. From your previous exponent training, why did I circle those? Because they're negative. Okay. Yes, exactly. And what I have to do is use the reciprocal, just like Hallie said. Okay. What I mean by that is this one is going to go to the bottom, and this one is going to go to the top. So let's follow their path. On the top, I have 4m to the 4th that was there already, right there. And then the circled guy comes up and becomes m to the positive 1. Okay, on the bottom, I have p to the 4th that was already there. And this guy is going to come down and become positive p to the 4th. So they switch signs when they take the reciprocal. And that is the way that we fix the negatives. Okay, so now, how many m's total are on the top? And how many p's total are on the bottom? Is that helpful, maybe? And we'll keep sprinkling those in. Just for your assistance. Okay. Next thing we need to talk about is I'm going to change up the order of things a little bit because of our quiz. I feel like the classwork that we're supposed to do tomorrow is actually more helpful for our quiz today. Are you going to be okay if your notebook is slightly out of numbered order? Okay. I know. I think I might be the one who had the hardest time with this, but because I'm a linear thinker. But okay. So this is what I want to do because I've really thought about how best to help you guys with the quiz. I'm going to do 114 and 115 today, which has the notes in it. Then we're going to work on the whodunit. Then we're going to do our quiz at the end. If I were you, and if you've tuned me out in the last 30 seconds, tune me back in right now, I would do this homework tonight. But here's the deal. I will just not stamp either one of these until Monday. So you can do them in any order that you like, the homeworks. This is me trying to be flexible. Not a strong suit I have. As you can tell from the fact that I printed out a packet that goes 3 weeks in advance. So anyway, by the end, we will have all of the things done. I am just switching up the order because I want you to do really well on this quiz because I saw Miss Rice's 5th period quizzes yesterday after school, and I think that I want to do this. I don't love, I promise. So I'm going to attempt to cover every single possible thing that you might find from an arithmetic sequence, um, except when they give you like 2 points and you have to find the slope. I'm not going to go over that again, but this is all about notation, explicit, recursive, um, finding a term, all that stuff. Okay. First thing I want to ask you guys is, what does this word mean, arithmetic?
Adding and subtracting.
Perfect. Adding or subtracting. Okay. So what I want to do here is I want to take my red pen, and you guys can do any notation that you want. I'm going to put n equals on the bottom here and put a little baby 1, 2, 3, and 4 so that I can see what term those are. So this is basically spot 1, spot 2, spot 3, and spot 4. And then I'm going to do my thing right there that's going to help me in a minute. Arithmetic sequences have a common difference, which is their growth. What is the growth in this problem? 4. And what letter do we use for that? Perfect. I must not have put you that asleep. Okay, now we're going to find the explicit equation. And the explicit equation is going to look just like y equals mx plus b, but remember, it's got fancy notation. So t of n equals d n plus t0. But I really want you to see that y equals mx plus b living there. What is t0 in this problem? What would be, you guys all see the -9? Everybody see the -9? -9, -9, -9. Okay. Over here, I'm just going to write that. I don't want to put -9 there because it's going to make it look like -9 is part of the sequence, and it's not. So I'm going to write it over here. So my explicit equation is T of n equals 4n plus cripes. That should be minus 9. Okay, recursive was the new thing that we did on Monday. We have not gone over this a whole lot, so this might still be confusing for you. If it is, that's totally okay. Recursive equations have the same exact setup, for lack of a better word. So they always look like this. When you do a recursive equation, you can just write down that part. That part is the same every single time. And it doesn't matter if it's arithmetic or geometric, it's the same every single time. And I only have to do two things. I have to say where it starts, first term, and I have to say what's happening to it. The first term in this one is -5. So I put -5 in there, and that piece is done. And then let me read this to you again in words so that you can see what this is saying. So it's saying start your sequence at -5. To get the next term, take your previous term and add 4 each time. So let me say that in words again. Start your sequence at -5. To get the next term, take your previous term and add 4 each time. That's what recursive equations are saying. Okay, next thing I want to do is come over here to this, and I want to graph these. So this -5 is term 1. So that means that the coordinate is 1, -5. So you're saying the first number is -5. The second number is -1. The third number is 3. The fourth number is 7. And do not connect the dots, as satisfying as that might be. Do not connect the dots, but the dots should be in a linear pattern. Do you guys remember why we don't connect the dots? Anybody know why we don't connect the dots? Yeah. Yes, exactly. There's no spot 1.5. There's no spot 2.76. There's no spot pi. It's just spot 1, spot 2, spot 3, spot 4, discrete spots. Excellent, excellent answer. Okay. We're going to do 2 more things with this, and then we'll move on to geometric. Does anybody know what, in words, what this is saying, what this is asking? What question is this asking in words? Sam? Find term 30, which means if we translate that to teenager, find the 30th number out, right? Okay. And Sam, do you know how I can find term 30? Yep, great job. So Plugging 30 in there, just like it's a function machine, because it is. And then last question we're going to answer. So what I mean by this question is if I continued my numbers out for a really long time, let's just say I had nothing to do like all the rest of this period through access, and I just kept listing numbers up four, up four, up four, up four, would 400 be one of those numbers? Is what it's asking. And to change this into notation, I'm going to say, will T of n ever be 400? Will there ever be a term that's 400? I'm going to say I think not, because they're all odds, right? Are they going to be odds always? Okay, but let's just do it for real. So what I'm going to do is take 400, instead of plugging it in for n, you plug it in for T of n. So you do 400 equals 4n minus 9. So this is like a backward function machine. Plus 9, plus 9. 409 divided by 4 is 102.25. Does that make sense? Can you have a spot in a sequence that's spot number 102.25? No, this is not like the Hogwarts Express here. Can't get on platform 9 3/4. It like literally has to be whole numbers. Okay, so we already kind of knew, but is 400 a term of the sequence? No. Okay, and what we're going to say is no. N has to be a positive whole number. N has to be a positive whole number. N is the spot that it is, not the number in the term. So, and we sort of cheat by saying term 0 for this to find our equation, but you can't go backwards. And if you want to talk calculus, I can talk calculus and talk about how you can go backwards, but we don't want to do that in math 1. Because technically you can go backwards. Yes, yeah, yes. What? Yes, this is still 114. So just the spot number has to be a positive whole number, not the number in the sequence itself. Yay. Sometimes I think teaching adults would be easier. But I probably wouldn't get as fun of entertainment as I would, as I do now. You know, Mike, I think I answered your question wrong. I think this is number 115. Sorry about that. Mike, did you hear me? Did you hear me? I think I answered your question wrong. I think this is number 115. Sorry. I said, I think I answered your question wrong. This is number 115. I just forgot to put the label there. Sorry, honey. My bad. That's a child after my heart right there. Okay, so let me start this the same way that I started before. What does geometric mean? Multiplying. Great. Okay, and geometric has something different. It doesn't have a common difference. It's called a common ratio, which is R. And can you guys tell that the multiplier is 3? Okay, so R is 3. I'm going to do my same little notation under here. N equals 1, 2, 3, 4. And then my arrow back. What would term 0 be for this problem? 2. Excellent. So when you go this way, you multiply by 3. When you go backwards, you divide by 3. Okay. Explicit equation. This is multiplication. So it should look like y equals ab to the x, but with fancy notation. So t of n equals t0 times r to the n. But I really want you to see the y equals ab to the x living there. And so this would be t of n equals 2 times 3 to the n. Okay, as I said before, all recursive equations have the same setup. They all look like that every single time. The only thing we need to do for each of them is fill in where the sequence starts and what's happening to it in the growth. So this is saying our first term is 6. To get the next term, I take the previous term times 3 each time. Okay, the next thing we're going to do is graph the dots, and we're going to graph them at the best of our ability. So the first dot is at 6, which is going to be just a little bit under halfway of the first box. Second dot is 18, which will be right under the 20. Third dot is 54, which will be right under the 60. Fourth dot is 162. And to be honest with you, that's as far as we can graph, as you can tell. Should I connect them? No. And does it make sense to you that it's curved? So discrete means leave them dots, don't connect them, but you should get a curve. Okay, 2 more questions to answer, then we're done with this. 5, term 9, which means the 9th number out. In this case, you have the board. It might just be easier to go on the calculator and do times 3, times 3, times 3, times 3, and follow the pattern out till you get the 9th number. That's totally okay. We're going to use the equation because it's right there. Do you guys know how to do the exponent on whatever calculator you're using? It should look like this. This is called the caret button, not to be confused with the thing that horses eat, and not to be confused with how big a diamond is. It's CARET, which is a little upward arrow over here. So let's practice 2 times 3. And then when you hit that button, you have to say it to yourself, but you have to say it like that, like you're like really into it. You got to say it like in your mind. So 2 times 3, 9, 39,366. Last question on these notes, we're done with this. So you remember how when we did this with the arithmetic sequence, I took the number and I plugged it in the T of n spot. You guys don't know how to solve that. As a matter of fact, we're doing that in Math 3 right now. If I ask you if something is a term of a sequence in a geometric, you just have to keep multiplying. So what I mean by that is you're going to go, okay, 6, 18, 54, 162, and then you're going to go on the calculator and go times 3. What did I do? Times 3 is 486. Times 3, 1458. Times 3, 4374. Oh, cripes, I could have been done, huh? Oh, I went too far, but it's okay. Okay, is 1400 a term of the sequence? No. Don't worry, Cheryl. He's too busy looking at bikes. Absolutely not. He knows I'm furious about it. I've been furious about it for weeks. Hmm. Okay, now can you guys get back in your packet and find the page that says quiz review? Okay, the next thing I need you to do is take a look at your quiz review and tell me if there's anything that you need, any questions. What? You did the front page with me, most of it. The back page was homework. But I need to know if you need help with any of the problems. We did 4 together. Oh, what did I not do? Okay. Okay. And we don't know how to do the recursive? You're serious? Okay. Just checking. I wasn't sure if it was a joke. Okay. Okay, recursive. Okay. Does it? No, somebody's gone. When they get back. Okay. Does it make sense what I said in the notes about they start the same way each time? Okay, perfect. Okay. So, oh, I see. You can do the recursive. It's just you don't have the stuff. Oh, okay. That's a completely different question. Okay. No, no, no. Not your fault. Not your fault. Okay. Okay. All right. So -30 is term 0, correct? Because it was B. Does that make sense? Okay. So now if they're going up by 6 each time, what would term 1 be? Beautiful. I see. This is my bad. No, of course. Okay, now what else was there? Did we do everything else? No, we didn't find term 30, but I'm sure you know how to plug in 30. Yeah, you're right. You're right. You're right. Trust. Always should trust. Okay. What else besides that spicy bit? Yeah, you're supposed to. I was too lazy. I only did the first 2. But it would be -12 and then -6 and then 0. Anything from the back, guys? 7? Mm-hmm. Did you do it and then are you getting the wrong answer? Or is it? Okay, so first thing I'm going to do is distribute. I missed you, by the way. I didn't get to see you, and then I wasn't here. 16x plus 33. Okay, does it make sense that this is plus? Okay. Okay, and does it make sense that this is plus? Are you guys over there still laughing at the fact that I thought that problem was easy? It wasn't. Right. Okay, now I'm going to combine like terms really grossly. And are you get it from there? Like, okay. Okay. My arrow things are not great. But you get what I'm trying to do. Okay, okay. Okay, anything else from the back? 12. Oh, is this the one that you were trying to do binomial theorem for? Okay, but you don't need to. Okay. As fun as that is. Okay, so this piece right here, I'm gonna take this and write it out twice. That shows me that I need the box. So if you take that and you write it twice, then you can see the box that's necessary there. Okay, now this, I'm going to distribute the negative. Jules, remember that question you asked me like 2 weeks ago? What do I do with the negative in front? You distribute it. So this is going to become minus P minus 17. You don't distribute the thing in front of it, just the negative. Excellent. Great job. Okay, and then Talia, can you see right there? I'm going to do 35 minus P squared minus 10P squared. Okay, now what did I say to you guys about math 1? The P squareds will always cancel. And if they don't, that means that you did something wrong previously because we don't teach you how to solve squareds until math 2. The camera placement. Is that one better? I think it was just the first step, right? The box. It worked. Yes. Let me just quickly. We need to take our quiz. So yes. So number 11, you're gonna do a box for these two. Does that make sense? And then you're gonna get 3x squared and 3x squared, that's gonna cancel. Do you want me to? Are you sure? Okay, okay. All right, so this one. Jules, you want to distribute first. What? Is that what you were wondering? So, and when you distribute a whole number to a fraction, you just multiply the top only. So this is 8 times 3 is 24. 24 divided by 2 is 12. So 12k. And then minus 64 minus 3 over 2k equals negative 85. Okay, and then what's the least common denominator? There's only one denominator, so that kind of made it confusing. Do you get it from there, honey? So you have to make sure to multiply everything by 2. And on that fraction, just the top. And then it will come out even. Miss Lorraine, what is your what's your face?
That first multiply by 2, what are you multiplying that by? So you multiply it by 2 to get rid of the fraction in the bottom, and then on the other side. But did you multiply it by 12 and by the negative? What's that first?
The 12k?
The first dot 2 you have multiplied by 2.
You have to multiply
64.
Yeah. So this times 2 is for the 12k. This times 2 is for the 64. This times 2 is for the 3. And this times 2 is for the negative 85.
I missed the first one, and that's why I was looking confused. The first one I thought was the number 2 dots. I gotcha.
Oh, I see what you're saying. Everything, yes.
You didn't have a parenthesis or anything.
No, I got nothing. Well, I got rid of the parentheses in the mhm. Okay, guys. So can you find the next page in your packet that has the whodunit in it, please? I'm gonna show you how to start it. And then, yes. Yes. It is, but I'll show you this one. Oh, sure. Okay. All right, so there are 10 pink envelopes around the room. Each of them have clues in them. And they start out extremely easy. So, and the 10th one, I don't actually know if the 10th one's the hardest. The 10th one is supposed to be the hardest. But anyway, there's one clue in each of those pouches per table, not one per person, one per table. So send up, we're going to do number 1 together, but send up a person to grab the next clue. And it says, this was so easy. Find the 5th term of the sequence. Okay, so what is this going up by? 7. Okay, so plus 7. So the 5th term would be 20. Okay, that means that the 5th term is 20. This is the correct answer. And so what you do, I don't even know what you would write here. Woo! Okay, so what you do is you come back over to the whodunit part and you take the answer and it says the injury was not done by chemical poisoning. So then you cancel out chemical poisoning as a possibility. It's like clue. Yeah. Yeah. It's like clue. And then the one, when you're done, if you did it right, one person, one place, and one method should be left over, and that will be who did it. So, I'm gonna give you guys. So you're not gonna finish this today, and it's absolutely okay. I'm gonna give you, I think, 15 minutes or so, and then I'll call you back and we'll do our quiz. If you don't freak out if you don't finish it. I'm going to give you time tomorrow. It's not a big deal. Just do what you can. Does that make sense?
Yeah.
Okay, all right, go ahead. Clue number 2 is right there. You don't have to do it in order. What? That one's number 1. You don't need that one anymore because that one's number 2, and then that one's number 10.
Okay.
Yeah.
Can I just grab the paper and go back to my desk and work on it?
Well, there's not enough for everyone to have their own, just one per table. So if you do, just put the clue in the middle of the table so everyone can see it.
Got it.